Good afternoon, everyone. Is there any doubt related to last two chapter? If you're not having any doubt, we'll go for the next one. My voice is audible.
Yes,
Yes,
ma'am.
ma'am.
Okay. So now in this lecture, we will introduce the third topic, that is Hamilton's principle. Okay. The name of our topic is Hamilton's principle. Okay. In that, first we'll see what is Hamilton's, right? After that, we'll go for the derivation of Lagrange's equation of motion by using Hamilton's principle. Okay. So first, let us go for the statement of Hamilton's principle. Consider a dynamical system from one point to another point. Right. Suppose we have one system of n particles. Okay. A dynamical system from one point to another point within the time interval, say t0 to t1. Okay, the starting time is t0 to t1. Out of all those possible paths, a system will choose a path along which the line integral of Lagrangian is extremum. Okay, line integral of Lagrangian is extremum. Right? What is a statement? Consider a system of n particle or a dynamical system of n particle within the time interval from t0 to t1 will choose a path in such a way that a line integral of a Lagrangian L is extremum. Okay. Now, what do you mean by this statement? Suppose you are provided that you have to move from, say, position A to B within time interval t0 to t1, right? Suppose you are allowed to move from position A to B, or rather, whole class of MSc first. MSc first mathematics student are allowed to move from point A to B, because since we are considering system of n particle, so whole class of MSc first year mathematics students are allowed to move from point A to B within the time interval. Suppose the time interval provided to you is say 15 minutes. Okay. So according to that 15 minute, the what will be the t naught? It is 0. What will be t1? It will be 15 minute. Okay. So the students of MSc first year is nothing but the system of n particle dynamical system is allowed to move from point A to B within the time interval t0 to t1 means 15 minutes. So this will be extremum. The time in the system or dynamical system will choose a path in such a way that the line integral of Lagrangian is extremum. Okay. So this is not a theoretical part. That way I will explain you how the system will choose this path in such a way that the line integral of Lagrangian is extremum. Now my question is what here, if you are given with this situation, what you will do? स्क्रीन दिसतंय सगळ्यांना?
Yes, ma'am.
आवाज येते माझा?
Yes,
Yes.
ma'am.
Then answer. What is the answer for this situation? If a class of MSc first year student are allowed to move from position A to B within 15 minutes, which path you are going to choose?
Smallest path.
Smallest path, that is minimum path, right? So that here also it is the same thing. The system will choose a path in such a way that the line integral of Lagrangian is extremum. What do you mean by extremum? It is either minimum or maximum. But in this case, the system will choose a path in such a way that it will reach in a minimum time, that is provided time is t0 to t1. So here also you told that you will choose a path, a shortest path or a path in such a way that we require a minimum time. Okay. So this is what the principle in which a system of dynamical system is allowed to move within the time interval t0 to t1, then that system will choose a path in such a way that the line integral of Lagrangian is extremum. Correct? So now, in another way or alternate statement for this is, if the line integral of Lagrangian, if the line integral of Lagrangian is extremum, if line integral of Lagrangian is extremum, then delta variation in the value of integration I must be equal to 0. Delta variation in the line integral of integration I must be equal to 0. Right? Now what do you mean by extrema? Either minima or maximum. How are you going to find out extrema? By using the derivative, that is first derivative equated to 0. So here also if the delta variation in the value of integral I equal to 0, it is nothing but the integration I is a extremum. Those who remember the second chapter, in the second chapter we have proved Euler-Lagrange's theorem by using dou I by dou alpha equal to 0. Or in another way, we have proved the same thing for delta variation, delta I equal to 0. आठवते का?
Yes, ma'am.
Yes, ma'am.
So here also the statement means that the system of dynamical system is moved from point A to B within the time interval t0 to t1. It will choose a path in such a way that the I will be extremum. What do you mean by I is extremum? You have to find out the first derivative of I, which should be equal to 0. Here also the statement says that if a line integral of I, if a line integral of Lagrangian is extremum, then the delta variation in the value of integration I is equals to 0. Okay. Any doubt with this definition?
No, ma'am.
Derivation of Lagrange's equation of motion. Derivation of Lagrange's equation of a motion. Whether you remember Lagrange's equation of motion that we have studied in the first chapter? अभ्यास चालू करायचा आहे. इंटरनल डिक्लेअर झाले 10 मार्च पासून. आज 2 तारीख आहे. जर तुमचं रिव्हिजन झाला असेल तर 2-2 दिवस एक पेपरला सफिशियंट आहे. जर अजून अभ्यास सुरू नाही केला तर मग अवघड आहे.
d by dt of dou L by dou Qj dot minus dou L by dou Qj equal to 0 for
that is what
conservative system.
Lagrange's equation of motion for conservative as well as for non-conservative. But for partially conservative, it is equals to Qj t dash. Right? So what we have to prove? We have to prove Lagrange's equation of a motion by using our Hamilton's principle. What is Hamilton's principle? Dynamical system will move from position A to B within the time interval t0 to t1 in such a way that it will choose a path so that the line integral of a Lagrangian is extremum. What do you mean by extremum? Delta variation in the value of integration I should be equal to 0. Okay. So let us start with the proof. We have to consider system of n particle system of n particle which moves from say point A to B or P to Q within the time interval t0 to t1. Okay, again we have to find out, let us consider all the possible path from point A to B or from point B to Q that we can denoted by qj of alpha of t. Okay, what is alpha? Alpha is a parameter which gives, that means for different values of alpha we get a different curve, right? Now consider the integration I from t naught to t1 L dt. This is what your second equation. What is your first equation? All the possible paths from point P to Q. What is given to us? We have a system of n particle. In this case, a system of n particle is moving from say position P to Q within the time interval and they will choose a path in such a way that the line integral of Lagrangian is extreme, right? So this is what the situation given to us. Now out of all those paths that are moving from point P to Q, we are going to name it as Qj of alpha of t, where alpha is a parameter of alpha. We get a different path from point P to Q. Okay. So now, where L is a Lagrangian in our equation 2. Now, if I want to verify or if I want to prove the Lagrange's equation of a motion, I must know what is L. L is nothing but a function of qj dot nt, correct? Whether you remember this, L is a function of
Yes,
qj
ma'am.
dot nt. Okay. Now, by Hamilton's principle, out of all those possible paths, the system will choose a path along which the line integral of Lagrangian is extremum. That is, delta I should be equal to 0. So now let me find out delta variation in the value of our integration I. It is equals to 0. Okay, so which means that delta variation in L is nothing but qj dot or qj dot will write nt dt equal to 0. Okay, now let us find out the value of delta L. Yes, can anyone tell me how to find out the value of delta L now? Hmm. You don't remember this? Let me write down summation over j, because as this is not only for single one, it is not for q1 or q2. We are running for every variable. So hence let me write down summation over j dou L by dou Qj into delta Qj plus, what is the next term? Summation over j dou L by dou Qj dot into delta Qj dot plus dou L by dou T. As there is no parameter j here, so simply we can write dou L by dou T instead of summation into delta T dt equal to 0. Any doubt with this step?
No, ma'am.
How you found this? We have to use a chain rule. If you want to differentiate or if you want to find out delta variation, first you have to differentiate L with respect to Qj, then you have to find out a delta variation in Qj. Or if you want to find out with respect to alpha, it is dou L by dou Qj with respect to alpha. Dou L by dou Qj dot with respect to alpha. L with respect to T with respect to alpha. Right? Now, and the next step, as we know that there is no variation in type, right? What is the instruction? You have to move within the time interval t0 to t1, right? There is no there is no another choice for time. So since if there is no variation in the time along any path, even at the endpoint, say we can have here delta t equal to 0. Why delta t is 0? Because t0 to t1, it is already fixed out. You cannot change this time interval, right? What is your job? You have to move from point A to B within the time interval T0 to T1. Okay, there is no special case. You are allowed to move within the time interval T0 to T1. And that's why we can say, as there is no variation in the time at the end point, hence delta T equal to 0. Right? Let me show you one example. Suppose you are allowed to move from uh, suppose position A to B, correct? Or say position P to Q. Okay, we are going to provide you the time interval T0 to T1. Suppose it is 15 minutes. You have to move from position A to B within 15 minutes, right? There are so many paths, right? From P to Q. You can go here, you can go here, and then come back to this. Okay, or rather, if you want to go to Pune from Solapur to Pune within 4 hours or 5 hours, if it is given. So some may go directly. If 5 hours is given, directly we may go by minimum path, right? Or if someone may go to Mumbai and then come back to Pune, that is also possible. So out of all those paths, we are going to select the path for which we require a minimum time, right? Now, uh, suppose someone has chosen a path that he or she will go to Mumbai and then come back. तो जिसने वो पाथ चूज किया उसको हम एक्स्ट्रा टाइम नहीं देंगे ना. Time interval is fixed out. What is that time interval? T0 to T1. You may go from any path, right? So that's why we can say delta T equal to 0. There is no variation in the time. Okay. Have you understood this step?
Yes, ma'am.
Yes, ma'am.
So delta T equal to 0. Now next step we can write summation over J dou L by dou Qj delta Qj plus summation over J dou L by dou Qj dot into delta Qj dot E to dt equal to 0. Correct? If delta T is 0, the third term will be 0. Okay. Now let us find out the relation. That means actually this is a relation given to us. D by dt of delta is exactly equal to delta of t by dt. Actually, I also don't know why this relation is like this. What is a proof for this statement? But actually now we have to use, so that's why I am using this. If you get the proof for this, you can also send me that d by dt of delta is equals to delta of d by dt. No doubt we will get the proof of this, but actually now I am not having the proof for this. That's why I am saying you clearly that I don't know the result for this. So for that, now we have to find out the terms delta qj dot. Okay. So for that, we are going to use this result delta qj dot is equal to delta. What do you mean by qj dot? It is nothing but d by dt of a qj. Now in this case, we are going to use this relation delta d by dt is nothing but d by dt of a delta. So that's why we can use that relation and we can get it as d by dt of delta qj. Okay. Except this, we can now find out the value of a delta qj dot. So using this equation in above equation, we can get the equation as integration t0 to t1 summation over j dou L by dou qj into delta qj plus summation over j dou L by dou qj dot into delta qj dot. We have written it is d by dt of sorry, here it should not be qj dot, d by dt of this is qj, no, so this is not qj dot, so d by dt of a delta qj. Okay, simply qj dot is nothing but your d by dt, that is derivative with respect to t. We are going to denote it by dot. Simply by using this condition we have used. Okay, so integration with respect to t equal to 0, right? Now what is the next step? We have to find out the value of this integration, right? So before finding the value for this integration, what we can do is we can find out the value for this one. Okay. Because we don't know what is L. So hence we will keep this as it is. Let me name this as some equation number. What the numbers we have given? Actually, no number is given. So let me name it as some equation 1. So in this equation 1, if we want to solve this equation 1, we cannot do anything for this term. We don't know anything. So let me apply the integration for the second term. Okay. Let me consider integration T0 to T1 summation over J dou L by dou Qj dot into d by dt of delta Qj into dt equal to 0. Okay, no need to put it equal to 0. First we'll find out the value of the second term, right? So for that, let me write down. First we'll have this summation over j dou L by dou Qj dot as it is. First term as it is. Let me find out the integration of the second term. As integration and derivative both are with respect to t. So what will be the resultant of this one? This term. Sanga काय येईल result? Integration is with
Delta Qj.
t and derivative with respect to t. So resultant will be delta Qj within the time interval T0 to T1. Correct? On this T0
Yes, ma'am.
we have to apply for whole term minus the integration of derivative of first term. What is our first term? Let me take this summation outside. D by dt of dou L by dou Qj dot into delta Qj, right? And integration with respect to t, right? Minus the integration T0 to T1 summation over j t by dt of dou L by dou Qj dot delta Qj dt. Okay, now what is the value of this term? Can anyone tell me? Okay, what we have written here, Qj is equals to Qj of alpha t. What do you mean by this? These are nothing but collection of all the paths which are from P to Q. Okay, out of all those possible paths, we are going to choose a path in such a way that we get a correct path, or we can say the path from which we get a minimum time. Within the minimum time we can reach. For different values of alpha, we get a different curve, right? All the paths that is passing from point P to Q are denoted by the notation Qj alpha of t. Now, what is delta Qj? That is very small variation in Qj, just like a delta t, very small variation in t. And we have written delta t equal to 0 since T0 to T1 is fixed out. No one is allowed to have a extra time. Okay. So that's why there is no variation in time, and that's why we have written small variation in t is 0. Here also, is there any variation at the endpoints?
No, ma'am.
So what we can say about delta Qj, because we have fixed out the position P and Q. We are not
Zero.
go from any point to another point. So simply the positions are fixed out P to Q. So if there is no, since all the paths are starting from point P and they will end to point Q, there is no variation in the end point. So we can say that delta Qj is equal to 0. Okay. So what we get the value of this second term integration, we are evaluating the second term now. This term we are evaluating. So value of that term, we get it as minus integration T0 to T1 summation over j d by dt of dou L by dou Qj dot delta Qj equal dt, right? So now using that equation, we can say this is equal to this value of equation is nothing but summation over j dou L by dou Qj dot d by dt of delta Qj dt. Okay. So value of this whole term, that is second term in our integration, that is equation 1. From equation 1, the second term, value of the second term, we got this one. Okay. So using that term in our equation 1, we get what we get the first term as it is integration t naught to t1 summation over j dou L by dou Qj into delta Qj dt minus. Okay, value of the second term is with negative sign t naught to t1 summation over j d by dt of dou L by dou Qj dot delta Qj dt equal to 0. Any doubt up to this statement? Okay, if not, this integration, this summation with respect to t, with respect to delta qj, all this term we can take a common, right? So let me write down t naught to t1. This summation over j is also common. And what are the terms remaining in the bracket? If we are going to keep delta qj and dt outside, we have remaining terms are dou L by dou qj minus d by dt of dou L by dou Qj dot. Okay. Now, what we can say about this, since Qj's are linearly independent. Why Qj are linearly independent? Qj independent है. What are Qj? Qj's are nothing but your generalized coordinate. What do you mean by generalized coordinate? Least possible number of linearly independent coordinate. कालच्या लेक्चरला चालू करून ठेवले होते का असंच? कालच्या लेक्चर मध्ये रिपीट केला होता ना मग हे डिग्रीज ऑफ फ्रीडम इज नथिंग बट लीस्ट पॉसिबल नंबर ऑफ लिनियरली इंडिपेंडेंट कोऑर्डिनेट दैट इट इज नंबर and this is generalized coordinate at least possible number of linearly independent coordinate. So qj are linearly independent. Okay, if qj's are linearly independent, what will be delta qj? They are also linearly independent, and hence okay, let me take you one example of linearly dependent and independent. What is C1, Phi1? Suppose if I want to prove Phi1 and Phi2 are linearly independent, what you do? You are going to assume C1, Phi1 plus C2, Phi2 equal to 0. And if C1 is equal to C2 is equal to 0, then we say that they are linearly independent. And if at least one of them, that is either C1 is non-zero or if C2 is non-zero, then we say that Phi1, Phi2 are linearly dependent. Knowing this?
Yes, ma'am.
Yes, ma'am.
So here, what is given to us? Qj's are nothing but generalized coordinate. What is the definition of generalized coordinate? Least possible number of linearly independent coordinate. So if delta qj is linearly independent, so if delta qj is linearly independent, so phi1, phi2 are also linearly independent if the constants c1, c2 are 0. So this is all. This can also be written in the form of this one. This C1 phi 1 I can write it as summation over I Ci phi I. So this summation we can extend or we can write it in the form of a sum. Then this term will be treated as a constant and this is what your function. Correct? Getting me?
Yes, ma'am.
Yes, ma'am.
Okay, C1 phi 1 प्लस C2 असं लिहिलेत ना. इथे पण आपण समेशन ओव्हर जे रन केल्यानंतर काय होणार आहे, first term will with respect to Q1, second Q2, Q3 and so on. Okay. So here if C1, C2 are 0, we say that linearly independent. So if Qj's are linearly independent, then we say that this constant will be equal to 0. And hence we can say now that whole term, that is dou L by dou Qj minus d by dt of dou L by dou Qj dot will be equal to 0. And hence this is nothing but your Lagrange's equation of a motion. Okay. Read it once, whatever we have written here, and then we'll go for the next one. What is given to us? We have to use a Hamilton's principle in such a way that we have to prove Lagrange's equation of a motion. Okay. So for that, what is given to a system of n particle which will move from point A to B or point P to Q within the time interval T0 to T1. Out of all those possible paths, the system will choose a path along which the line integral of a Lagrangian is extremum. Okay. The example I have given you, class of MSc first year mathematics is allowed to move from point A to B within 15 minutes. So what you people will do, you will choose a minimum path. So for that, now delta variation in the integral I will be 0 if integration I is extremum. Okay, just like our first derivative equal to 0. Then out of all those possible paths, we are going to select the path for which the time interval is minimum, and hence this Qj alpha of t will denote all the possible path from point P to Q. For different values of alpha, we get a different curve. And then simply you have to find out the value of delta I equal to 0. Then use this condition. Since I also don't know what is a proof for this, after using this condition, make a find out the value of the second term from equation 1. After finding the value of the second term from equation 1, we get the result. And in this result, if Qj are linearly independent, delta Qj's are also linearly independent by definition of a generalized coordinate. And hence we can say the value of those bracket is equal to 0, and hence the result. Okay. Any doubt?
No, ma'am.
Okay, let me take the next one. If L is a Lagrangian for a system of n degrees of freedom, satisfying Lagrange's equation of motion, show that the new function L dash. Okay, let me write down the statement. Up to then, you have to read the statement and explain me what is our aim to prove. Read it and explain me what you have to do. Have you read it?
Yes, ma'am.
सांगा काय करायचं आहे.
We have given L is Lagrangian function for n degrees of freedom, and we have to show that L dash is also Lagrangian function which satisfies the Lagrangian equation with the help of Hamilton's principle.
Correct. Okay. Show that the new Lagrangian satisfy if L is a Lagrangian for the system of equation, then L dash will unchanged with the Hamilton's principle. Sorry, it should not be so that. Okay. We have to show first part. What we have to show? Show that the new Lagrangian satisfy Lagrange's equation of a motion. Okay. New Lagrangian must satisfy the Lagrange's equation of a motion. Okay. Part first to show that L dash satisfy Lagrange's equation of a motion. Okay. That is to prove that. What is our aim to prove then? Dou L dash by dou Qj minus d by dt of L dash with respect to Qj dot is equal to 0. Okay. So L dash is with us. What is your L dash? Is L plus d by dt of f of Qj t. Okay. Now for if you want to show that L dash satisfy this equation, what we have to do then? We have to first find out the value of L dash with respect to Qj, then L dash with respect to Qj dot. Then we have to subtract these two terms by differentiating second term with respect to t, and we have to show that this subtraction of these two terms is equal to 0. Are you getting?
Yes, ma'am.
Okay, let me find out the first term. Before finding that, let me first evaluate this L dash. Because since j is running for 1 to up to so on n, hence this is plus. What is d by dt of f with respect to qj? F is a function of qj and t, derivative of f. How you are going to evaluate the derivative? This is summation over j. First you want to find out the derivative of f with respect to qk. Let me write down as qk because j we have already used. Summation over k, f with respect to qk and qk with respect to t, plus derivative of f with respect to t and derivative of t with respect to t. Okay? Any doubt in this step?
No, ma'am.
Okay. Now, what you have to do first, we will find out the first term, that is L with L dash with respect to Qj. Then we will find out the second term, right? Let us differentiate L dash with respect to Qj. Okay, dou L dash by dou Qj equal to, what is the value of this term? Dou by dou Qj, we have to keep it as it is. We have to differentiate the term L plus, this is summation over K, F with respect to qk, and here is qk with respect to t plus f with respect to t. dt by dt will be 1. Right? Now, what will be the value of this term? The first term we can keep it as it is. Plus, what is the second term? If you are going to differentiate with respect to qj, it will be summation over k dou 2f by dou qj dou qk. Okay, dou by dou qj, if you are going to apply here, it is dou 2f now. And this qk dot as it is, plus this will be also dou 2f by dou qj and this dou t as it is. Correct? Now, this is what your equation 1. This is the first term. Okay, this is what a first term from your equation says star. In this step, we have found the value of first term. Now let us find out the value of the second term and then we will subtract. Okay. What you have to find out now? You have to find out L dash with respect to qj dot, which is equals to dou by dou qj dot of, what is a term of L? L plus summation over k dou f by dou qk into qk dot plus f with respect to t. Right, so which is equals to L with respect to qj dot plus summation over k, this term as it is. Now if you are going to find out the derivative, this summation over k as it is, dou 2f by, this will be dou qj dot dou qk into qk dot plus dou 2f by dou qj dot dou t. Correct? Now, what is the value of this term? If you are not sleeping, you can tell me the value. What is f? F is a function of qj and t, right? And here in this step, we are differentiating with respect to qj dot. If you are differentiating with respect to qj dot, whether f is a function of qj dot?
No, ma'am. It is 0.
So dou f by dou t will also be a function of simply qj and t. So hence this whole term will be equal to 0, right? So what we get the value of the dou L dash by dou Qj dot equal to dou L by dou Qj dot minus plus summation over K dou 2F by dou Qj dot into dou Qk and Qk dot. This is what a second term from your equation. This is what the first term of equation, this is second term, but we have to find out the derivative of the this one. D by dt of L dash with respect to Qj dot is equals to, okay, let me find out d by dt of dou L by dou Qj dot minus, plus. Now we have to find out the derivative of this term. Okay, before that, sorry, actually there is a mistake. Hmm. You have to find out a derivative of L dash with respect to Qj dot, correct? This term will be as it is, dou L by dou Qj dot. But what about this term? Because as f is a function of Qj and t, I have applied here. The mistake was here only, right? If you want to apply derivative with respect to Qj dot, we have to see the function, no? What is f? F is a function of Qj and t. It doesn't involve Qj dot, correct? So if you are going to differentiate the f with respect to Qj dot, it will be 0. Hello?
Yes, ma'am.
So dou f by dou qk, it is also 0 ना. यहाँ पे आपका derivative, suppose f is a function of qj and t. What will be dou f by dou qk? It is also a function of qj and t. So hence for finding the derivative, what we have to do? We have to keep the first term. No doubt there is no change in the first term. First term will be same. Plus we have to write down this summation over k dou f by dou qk will be as it is, correct? And now we have to find out the derivative of qk dot with respect to qj dot, correct? Right, here it is dot now, so we can differentiate the second term. At that time this term will be treated as a constant, okay? So hence now if you remember in somewhere in the first chapter we have written the notation for this term. What is this term? Dou by dou qk dot by dou qj dot. Let me write down that think on this. आठवते का है डेल्टा के वजह? If not, let me write down what is qj dot and qk dot. हेच आहेत ना इथे derivative. What is qj? Qj is running for 1 to up to so on n. Qj dot will also run for say q1 dot, this is q2 dot, q3 dot and so on. Qk dot will also be say q1 dot, q2 dot and so on. And if you are finding dou qk dot with respect to qj dot, so what will be this? First you have to keep k as it is or j as it is. First let me keep k as it is. It will be q1 dot with respect to q1 dot plus what is the next term q1 dot as it is with respect to now q2 dot plus q1 dot as it is with respect to q3 dot and so on. So what are the values of this term? Can anyone explain me what are these values?
0.
Why it is 0? Because we are taking the partial derivative of q1 dot with respect to q2 dot. So here it will be 1. A equal to 1 when I equal to j. Otherwise it will be 0. So hence we write it is in the form of delta notations. Okay. So value of that term will be equal to 1 if we run the summation. No. If we run the summation somewhere if j is equal to k then only it is 1. After running the summation somewhere you will get 1. Otherwise it is 0. Okay. So hence in this state we can write it as uh, what is a term here L dash with respect to qj dot is equals to L with respect to qj dot plus f with respect to qj. After running the summation somewhere j will be equal to k. इथे j equal to k येणार ना इथे पण k after running the summation over k is equals to j. Here also k equal to j. So delta jj is equal to 1. All other are 0. Correct?
Yes, ma'am.
Okay. Now let us write down this. So what is the next step? We have to find out the value of d by dt of L dash with respect to qj dot. It is equals to what will be equal to d by dt of L with respect to qj dot plus d by dt of dou f by dou qj. Okay. Now this term will be as it is plus we have to find out the value of this term. Considering f as a function of qj and t, we have to evaluate the derivative of this. So for that we can write it as summation over j. This will be dou 2f by dou qj dou qk into qk dot. Right? Derivative of f with respect to qk, qk with respect to t plus next derivative of that is it will be dou 2f by dou qj into t. That is first you have to differentiate after finding f after considering f as a function of qj and t. First you have to differentiate this you have to name it as some function m. Okay, after considering this as m, you can find out the derivative of m with respect to qj, derivative of m with respect to qk, qk with respect to t. Next, derivative of m with respect to t and t with respect to qk. Okay, so now from you can name it as say equation number 3 and then subtracting these two equations, we get L dash with respect to qj is a first term and then t with this d by dt of L dash with respect to qj dot is equal to its value will be equal to what are those equation equation 1 and 3 plus summation over k dou 2f dou 2f by dou qj dou qk into qk dot plus next term is dou 2f by dou qj dou t minus t by dt of dou L by dou qj dot minus summation over j dou 2f by dou qj dou qk into qk dot minus dou 2f by dou qj dou t. So this plus minus get cancelled Okay, that plus minus will get cancelled and we get the result as dou L by.
And your screen is visible.
Okay. So we get it is equals to dou L by dou Qj minus d by dt of dou L by dou Qj dot. Okay. So here this is equals to our L dash with respect to Qj. This was our equation 1 minus d by dt of L dash with respect to Qj dot. So what is the value of this whole term? This is nothing but your Lagrange's equation, which is equal to 0, and hence we can say that L dash also satisfy the Lagrange's equation of a motion. Okay. Already time is late, so you can leave the meeting and you can join the next lecture.